Good evening, everyone. I'm Survi Sahai, Senior Content Writer at India IT 360, and I'm delighted to welcome you all to today's exclusive online session titled From Co-Pilot to Co-Workers, Are Enterprises Ready for Agentic AI? The evolution of AI is accelerating. We are moving beyond AI and simply response to prompts into systems that can plan, reason, and independently execute complex workflows. The big question is, are enterprises truly ready for AI that works autonomously? And to help us unpack this transformation today, we have with us Mr. Sumit Jain, Associate Director of AI ML Engineering at UnitedHealth Group. With over 10 years of experience in building billion-scale AI systems, Mr. Jain brings a rare blend of deep technical expertise and strong business acumen. He has also taught AI ML and big data at premium institutes. We are truly honored to have you with us, sir, today. Thank you for joining in. Before we begin, here is a quick announcement to make your experience even more good with India IT 360. We have launched our exclusive IT 360 Connect app designed specially for IT CXOs and tech leaders like you to expand your network, elevate your personal brand, and unlock curated rewards and perks. For all upcoming webinars, roundtables, and digital campaigns, we encourage you to register directly through the i360 Connect app for a faster priority booking experience. The download link has been shared in the chat box. Do install it to stay connected effortlessly. We will also be hosting question and answer segment towards the end of the session. If you have any question during the talk, feel free to drop them in the chat box and we will take them from there. Now, to make things more interesting, I'll invite Mr. Sumit Jain to lead us through today's conversation. Over to you, sir.
So this is Sumit. I've been working with uh, United Health Group at present. Previously, I worked with Microsoft, Reliance, Geo, Wayfair, Avaya, Control Case, and a few other organizations. I've been basically working core in AI machine learning from last 9 years or so. Currently at United Health Group, I lead a team of AI engineers and senior AI researchers who are mostly, folks who are particularly AI/ML experts, particularly working in academia and industries from quite a bit of time. I've been basically also working on building foundational models for healthcare side of areas with United Healthcare. We've been also building some of the research, publishing research papers, patents, also working on building products around LLMs and agentic systems. A lot of agentic workflows that we have within the products on, different use cases for extracting, contents from PDFs, extracting, building workflows for monitoring systems with agentic, backends, and then various other use cases for clinical assistants and doctors, agentic AI, and how resolving all of those things. I have worked on both the wide and deep systems that have something like GeoTV, or which particularly have like many heads into it, that particularly work on projecting content from like 28,000 shows per week, like GeoCinema, like almost all Netflix like content around it, building machine learning systems, recommendation systems, collaborative filtering systems, content-based filtering systems, and such. These are all in NLP, computer vision, recommendation systems, hybrid platforms. Something as deep as Windows, having almost 1.5 billion users, where I've been basically working with Microsoft to incorporate some of the areas in Windows, something like on the front of voice axis, you can search it for some areas of Copilot, and building prioritization system for different screen changes around that are happening within the Windows 11 operating systems. Um, I've been teaching from last 7-8 years in AI machine learning. Worked with various companies and at tech institutions. Lectured around at IIT Bombay. Invited for ISB and various other engineering colleges and stuff. Um, Recently, my current interest is building on agentic AI systems, on multi-agentic systems. So I think this call will be more or less towards showcasing some of those to you in this session. So, in this session, we'll be moving majorly towards beyond the generative AI era. So I would assume most of you are particularly aware of the Chat GPT and how it particularly revolutionized the generative AI era. So we're basically now in 2026, even in fact, even in more or less most of the 2025, we have entered into the agentic AI era. Uh, um, Moving forward, we effectively, for the last 24 months, the enterprise has been fascinated by the LLM's ability to speak. But in 2026, speaking is no longer a competitive advantage, which is more majorly advantages towards acting, right? So acting in the sense like how does a specific system acts on behalf of an entity. An entity could be human and already existing software systems, and how it particularly performs within those boundaries. So the evolution of the session is effectively engineered towards how the agents can be built. We aren't just talking about chatbots with a few plugins. We'll be particularly talking about the architectural shift from stateless information retrieval to stateful goal execution. We'll explore the engineering, the hard-coded reasoning loops, the memory architectures. Can you be in the first slide, please? Yeah. So memory architectures and hard-coded, how you authorize a machine to move your, let's suppose, a budget or even manage your customers around, right? So from the recently reports from it suggests at the end of 2026, the gap between the adopters and the architects will be permanent, right? The architects will have the systems. Hi, can you go on the first slide, please? I'll particularly be moving from the evolution. Okay, yeah, this one. So basically, it suggests that the most of the end of 2026, there will be the architects who will have systems that while they are basically sleeping, there'll be adopters who will stuck in the pilot purgatory. They will look at the, how the evolution has moved from architects who will be permanently building things up for the customers, and there'll be adopters who will be just consuming those things up, right? So as soon as we go into that particular phase, that means there will be most of the architects in the market who will be building these agents around for everything that is existing out there, and adopters who will be particularly just adopting them out because the architects have already built it out. So the evolution of effectively agents worked from the way where to build for the future, we have to recognize where the standard automation failed, right? In 2022 or 2023 was basically the era of scripted automation, right? These systems were deterministic in the sense that they have fixed rules defined. If else, if this happened, then this should happen. If this happened, then raise this alert or anything of those sort, right? This followed like the if this then that logic, right? They were fast, but they were brittle, right? They can break easily if there's something change that has happened in the system. So if the vendor changes a single line or an invoice, in an invoice, it will basically the automation completely broke. Let's suppose if you're parsing an invoice from a vendor, right? Similarly, in 2024, 2025, we brought reasoning capable agents. What are these? This was basically a co-pilot phase, you can assume. We integrated LLMs, the large language models like GPT, with specific tools like weather tool, or calendar tool, or any kind of a tool. Anything, any software can be converted to a tool, right? They could understand the nuance, but they were still pull systems, right? They sat idle until a human asked a question, right? They were stateless, effectively, what I call. Every time you started a conversation, the AI was effectively suffering from some kind of a amnesia. Like you particularly have to, you know, start the conversation from the beginning, or probably, you have to particularly prompt AI to do things out, right? Just like what you're doing effectively with ChatGPT, right? It particularly right now they're remembering things up from the back end, but initially when they're just using an independent GPT, they don't particularly remember too much of the system. So they were majorly pull system. They could understand what the nuance that you're asking towards, uh, but they will be not doing anything autonomously. They will be just waiting for the human to give a prompt to them, and then they give responses to the specific prompt. In the 2026 plus era, this is an era of full agentic autonomy, where we have engineered the brain to be more proactive. These systems effectively monitor things around autonomously. So let's suppose the event stream that is happening, or any system that is particularly having different action items that is moving within the system, right? So they use basically recursive planning, meaning that they don't just guess an answer. Effectively, they draft a plan, then they test it, and then against a simulation, execute it, right? So effectively, what is happening is the agentic system in a supply chain, let's suppose, don't just send a news alert, right? They present you with like three other routes, rerouted shipping routes, and they already vetted for whatever the cost and compliance that are coming up in that supply chain, let's suppose, use case. Something, just I take an example for it. So effectively, this agentic autonomy is making the system more proactive in nature than reactive to certain things, right? And this proactiveness effectively brings a lot of autonomy with the existing frames, right? Anything that is breaking in the system, the agent knows that if something is breaking, it tries to reroute it to the right path, let's suppose. So they have certain things defined, and based on those things, they particularly plan, and then they test it, and then against a simulation, then execute it, right? So let's suppose if a port's, all of the systems particularly failing, it particularly figure out the plan to not fail it, right? Autonomously. A human doesn't has to be involved into, because it sent an alert to it. So all this is particularly the agentic autonomy, and we'll just understand a bit on more. Okay, so the next part of it particularly comes up in a way where you have the core pillars of the agentic systems. How do we measure an agent, right? So we use three engineering KPIs. First is basically the reasoning efficiency. So in 2024, when we used to do, a model might take 3 turns to understand a complex prompt, right? If I asked him to perform some task, like, parse this PDF, extract these terms this way, extract a table this way, extract some things L this way, right? So I orchestrated a complex prompt, right? So in 2024, a model will take some, multiple turns to understand this prompt, then it's effectively solve things out. In 2026, we particularly measure the first pass task decomposition. What does this mean, like in a simple terms? So can the system take a very big goal, like let's suppose, if I say a CEO of a company gave like, reduce the quarter 3 churn of customers by 5%, right? The customers who are leaving the system, can you reduce the churn for that, right? And break it into, so what it effectively is, when you just give this specific goal, which is like a very high level goal, what the system does, a agentic system does, is effectively uh, break it into 10 executable engineering tasks or tickets without hallucinating. We are currently almost hitting 85% benchmark with specialized reasoning models in terms of, execution of these tasks. So can you go to the previous slide? The previous slide before this? Yeah, this one. So the second part is basically the tool integration rate. So the agency is defined by tools it use. That means if there are multiple agents, you're particularly defining how the tools are particularly they are using, the quality of the agent is defined by that. So if I'm saying that a world-class agentic system will now leverage, let's suppose, 12 plus deep integrations of different tools, right? It has tokens to access your ERP systems, your CRM systems, your even legacy mainframes through a secure API bridges, right? So via API, they're able to connect multiple tools and systems. So the tool integration rate has increased. The best agentic or an AI agent would be someone who's particularly access to like almost all the tools that it needs to particularly perform a task, right? And the third point is basically the autonomy depth, which is the ultimate metric, right? We track the seconds of human intervention per task. What it means is seconds of human intervention per task. So if we are moving from a world where humans do the work to a world where humans perform exception management. So if an agent, let's suppose, can complete like 20 steps of a 22 steps process, that is high autonomy depth effectively, right? So you're basically saying that this particular whole flow where, let's suppose, a contact center ticket is raised to a customer care, until the ticket is being resolved, there are like 22 steps it has been followed through, right? And if I make an agentic system that does 20 or 22 steps, it has a high autonomy depth, right? So it's basically very deep in the autonomy, and then there will be very few involved human in the involvement loop. So for the legacy automation, and so let's just compare a bit on what we were doing earlier and what the system, the AI systems at present have been capable to. So the most frequent point of confusion to the C-suite people is this new wave of AI, is this just an RPA 2.0? RPA, if you don't know, is robotic process automation. And robotic process automation is effectively automating how specific tasks are being done through certain specific tools like UiPath or Blue Prism and stuff, right? So these are basically RPA, which is robotic process automation, is a deterministic approach towards automating a lot of the workflow tasks, right? It lives in a box. It uses UI selectors to click buttons. If the button moves 2 pixels to the left, the robot dies effectively. So these are one of the challenges with RPA, right? So if I say that hey, if someone made a change in the it effectively works on the UI, and it basically do the same things that, let's suppose, I want to click a button, I want to send a mail, I want to do uh, other things, is particularly alerting specific stakeholders, and then executing certain tasks, right? So all of this specific workflow is bundled in an RPA system, right? Now if anything moves from its place, it's effectively break everything, and then this automation breaks, right? So what happens is this creates a massive maintenance depth, right? So what this happens is creates a massive maintenance debt, where effectively you have to maintain, where engineers spend all the time fixing the old automations. With the agentic intelligence, it becomes more probabilistic and dynamic, where it doesn't look for a button, it looks for a function, right? It uses semantic reasoning to basically navigate whatever the UI or API or the environment shift, and it basically, the agent in it reasons through those shifts that is happening. So RPA, you can think of it in a simple language, right? RPA is a train of tracks, right? It is fast, but it can only go where the tracks were laid years ago, right? Agentic AI, you can assume, is a self-driving car, right? It knows the destination, and if there's a roadblock on the road, or the road is washed out, something happened, it calculates the new route in real time, and basically figure out the way to reach to the destination. So it basically reduces your maintenance overhead by almost 60%, and basically allows an intelligence layer to scale without hiring more engineers to mind these robotic automation bots, right? So that's basically how the legacy automation and the agentic intelligence differentiates. Moving forward, the strategic implementation roadmap. So building agentic systems isn't about buying AI, it's about engineering logic, right? So when you have a phase one, which is basically modular reasoning, we have moved away from one giant prompt, which was basically hitting an LLM. We built small micro reasoners, right? So basically nothing but a small specialized logic loops that can handle one specific part of a workflow, right? It making the more system more stable and easier to audit. So let's suppose if I have a specific workflow in a supply chain, or maybe just like contact center use case, right? If a customer raise a ticket, how does the ticket moves from the customer's system to the portal of the the customer care executive, right? And what are the different checks it goes through, and how does that ticket particularly bundled with any specific metadata information, any other specific task on how to automatically answer that and present that answer to the a customer care agent, all of those things, right? So it basically specifically for that part of the workflow, there are specific logic loops that are defined, and that agent specifically handle that part of the workflow. So the phase two, what happens is there are certain digital guardrails. So you must effectively engineer certain borders, right? And if the agent tries to, let's suppose, pass to that or borders, those guardrails will prevent it. Let's suppose, right? So if the agent becomes more too smart, as particularly with the continuous workflow and the continuous process that is happening, because it's learning every day in the memory of it, will define the anatomy of agent as we in the next coming slide. So it particularly now performs autonomously in much smarter way within the can particularly go outside the borders, right? So there are certain digital guardrails that are defined where an agent cannot cross a certain limit. Let's suppose it's offering a customer who's leaving the system some 50% discount code, right? That if you don't leave the system, I'll give you a 50% discount for the next month's subscription, right? the While particularly in the lieu of preventing the customer in not leaving it, this is the age should not become too lenient in providing like 90% discount code to a customer, right? So those guardrails that it should be 50% discount code capped over it, is basically the hardcore engineering layer that is provided while the agent of autonomously learn in the system to particularly become better at preventing the customer to churn from the system, right? So so what happens is that this is the phase two of the strategic implementation roadmap. The phase three of it is basically the vector memory. We are effectively building a long-term corporate context where, using vector databases, our agents remember every interaction across the company. So if the legal agent finds a clause in a contract, the procurement agent knows about it instantly, right? So basically the vector memory effectively takes care of all the interactions that every agent is happening within the organization, and the updates particularly are being shared through a common vector memory that is being shared by multiple agents, right? And the last phase is effectively the human in the loop 2.0. So we have moved from if something happened, let's suppose an alert is raised and some rule has failed in the system, we wait for the human to particularly resolve that out. When the human resolves that out, then the process moves further, right? So we have moved from wait for human to exception triggers, right? So effectively what happens is the agent is now working at uh, full speed until it hits a predefined ambiguity threshold, which are effectively called either guardrails or ambiguity threshold, and only then it escalate to a human with a summary of the work already done, right? So if it can solve the work by its own, it will solve the work and resolve the issue by its own. If it's particularly hit some wall that some digital guardrails or some ambiguity threshold where it cannot decide which way to go, and it needs a human to take a call, and which is the most ethical way to go for, then only it will escalate to a human, whatever the summary of the work that is already done, right? And with the summary of the work that is already done. So These are specific implementation goals that an agent effectively performs. Moving to the next slide. Looking at the technical blueprint, this is the iterative orchestration layer, right? At the center is the orchestrator, which is effectively the brain. It receives the high level goals. Let's suppose take an example of an organization, right? And within an organization, the business layer of an organization receives the high level goals, right? And then it performs the task deposition. So let's suppose you have VPs in a company who's receiving the high level goals, and then they assign those high level goals to uh, directors to perform them further to from their team. So it perform a high level goal and perform the task decomposition there. So where, let's suppose take an example of supply chain. It breaks the fix the logistics. There's a problem with logistics that a company at a very high level says that there's a problem with the logistics of the company. It breaks the logistics, fix the logistics into check inventory, check shipper status, negotiate rates. If you do these specific small tasks, make it better, the fix the logistic overall goal will be completed, right? To left to the so in the left of the architecture, as you see, is a stateful memory. This is achieved through a combination of, let's suppose, high speed, something like Redis style caches and long form vector databases, which ensures that the agent has contextual continuity, right? So what is happening is a specific memory, or you can call it the past history of all the events that has happened in like sort of a cache. It basically store those in the memory, and based on that specific memory, it which is effectively nothing but a Redis style caching mechanism and vector databases combined, ensures whatever the contextual continuity is, like continuously providing the context to every new question that is coming to the agent or the new task that the agent is particularly picking up. So that continuous context has been poured in by the memory side of the architecture. At the bottom, the most important engineering advance is the reasoning and the reflection loop, right? Self-reflection loop, right? So effectively, what happens in 2024, if an AI failed, it just give you the wrong answer. I mean, it's confidently give you the wrong answer sometimes, right? That this is the answer for it, and it didn't even hesitate to give you a wrong answer. In 2026, the agent checks its own work, right? It runs a self-correction module, and if a database query returns an empty results, the orchestrator criticizes that query, right? Realize it used the wrong table name, or maybe like it corrects it, and then re-execute it, right? So the self-healing is what makes autonomy possible at scale, right? So this self-reflection and self-correction loop was one of the most important invention into this side of area, right? So it basically instead of just accepting what the answer AI is giving, it questions it, criticizes it, and then maybe like identify that where the problem in the query is, and corrects it, re-execute it, and then particularly having the self-healing mechanism continued, right? So that's how, and the tool integration is something that we have already discussed. So any MCP servers, any APIs, any databases, any web search mechanisms, anything that needs to be done, that is added as a tool, and the tool is integrated to the main orchestrator of the agent system, right? Moving forward, next slide. The industry use case. So effectively, in the modern contact center, let's suppose take an example of a contact center use case, right? uh, the contact center, you can say, is a front line of the agentic revolution. That's one of the topmost use cases for contact agentic revolution that could be implemented in industry. We are basically moving from a deflection to resolution systems, right? What it means is, legacy systems try to keep customers away from humans to save money, right? Agentic systems solve the customer's problem to save money, right? So what effectively it tries is, right, the legacy system, like we call an IVR, on a contact center, it will give you some resolution that, or even some chats on like Swiggy or somewhere. It will give you some resolution around, you know uh, maybe we'll just give you this resolution on, go to the FAQs, go to the previous resolutions tickets, something on those sides. So it deflected the issue of the customer effectively. Or in the end, it will then say that, we'll connect you to the customer agent, right? So the deflection is happening there of a specific issue. So the legacy system is trying to keep the customers away from humans, so less and less tickets or the customer queries goes to humans, and so that they save money in terms of the time that is invested by human in solving the customer query. The agentic system solves the customer's problem by to save the money instead of deflecting it from the humans. So a 2026 agent effectively doesn't answer a question. It initiates a doesn't just answer a question. It actually initiates a multi-step resolution process where it verifies the identity of the customer, check whatever the shipping API is, realizes that delay was, let's suppose, in the supply chain case, verifying the identity, checking the shipping APIs, realizing that there's a delay in the carrier, accessing the billing systems, issuing a credit, updating the CRM. All of that is effectively part of the resolution process. A human would be involved in doing all these specific checks to resolve that specific problem. But a multi-step resolution agent effectively is doing it autonomously now, right? So what is happening is, like, now, since you're having the agents are having access to so much of the data, the data has to be been made safe, right? So all customers data, effectively what happened is, uh, we effectively engineer something called PII scrubbing enclaves. PII is uh, private, personal data of the users. So all customer data is particularly now processed in a very secure environment, and LLMs within these agents effectively only see a tokenized version of this, right? So it basically not seeing the actual text that, this human name, maybe like Sachin Bansal or something like that, is uh, is this age, this phone number, this social security number, PAN card number, anything of those sorts, right? All of this customer data is processed in a very secure environment, and the LLM of the agent, which is the brain of the agent, effectively only see a tokenized version of this, right? PII redacted versions of these, right? So it allows the use of the cloud without ever sending a customer's personal data outside of a secure network, right? So effectively, those innovations actually prevent a lot of customers data that could have been exposed to the LLMs, right? Now, it also you also implement a real-time empathy scoring system, which basically takes care of where the agent monitors its own tone while talking to the customer, so ensuring it basically remains professional during the long and complex interactions, right? So all of this is particularly being taken care of while you're developing specific agents, and there's certain modules that have been built around this. Moving to the next slide. So when you effectively have a single, so there are like two kind of systems. You have a single agentic system and you have a multi agentic systems, right? A single agentic system effectively has a single agent in the middle that does whatever the task that is does. We effectively just showed, checked around, whatever be the agentic orchestration architecture is, where you have an orchestrator, planner, executor, and then the memory, the tools integrations, the vector databases and stuff, right? All of those are particularly within a single agent, what is happening, right? When you have multiple such agents in the pipeline, each of these agents are performing in a certain way, right? Now this performance of an agent within a certain multi-agentic architecture is something that we're going to study, right? How how a single agent particularly moved to a multi-agent system is effectively through a shared memory storage, right? All of this agent has a shared memory storage where the agent one, let's suppose you have three agents. So agent one could be researcher, agent two could be a negotiator, agent three would be an auditor, right? That all share a single world state where all of them has a single memory, shared memory storage. So what is happening now is a collaborative reasoning, right? So where I'm basically collaborating towards a certain reasoning on why this agent is doing performing this way, why that agent is performing this way, and all the agents is a context of each other, right? So instead of asking one model to be an expert in everything, that I have this one LLM model that does doing all the tasks, like I used to do by building prompts previously, I'm effectively building a team of agents. So agent one, agent two, agent three, and that team is effectively performing a overall task that is to be done. So if the negotiator agent tries to agree to a price that is too high, the auditor agent will come and look at the same shared memory and then blocks that specific transaction, right? Because it doesn't make sense, right? Similarly, in this effectively chart, it basically shows if I just look into maybe let's take an example of, let's suppose, a proper organization or hierarchical chart of a company, right? This whole system is effectively mimicking that human collaboration, but at the speed of a silicon, where the computer is executing the same task that a human is done. So you can assume that agent one, agent two, agent three are nothing but two, three humans that are working in sync. One is a researcher, one is a negotiator, one is a what I say, the mm, auditor in the system, right? So you're it grounding the AI into a digital business context, which is effectively your internal data, and connects it to a physical environment like your warehouse devices, or whatever, where the execution is effectively happening, right? And ensuring that the AI is actually acting, which we initially started, how the AI acts, right? And it is doing so with a 360-degree view of the entire business, right? Because it has access to all of this APIs, databases, information that it is given. So if you look into this, the agent one is effectively having a certain reason, uh, you know uh, the memory around it, whatever the goals is defined it, and then and the planner and the executor, the LM in the middle, how the tools are being coordinated and access the shared memory between the three agents, and whatever the digital business context, unstructured data, and all of that. I don't want to get into details about how the architecture is processing, but that is how an agent is effectively in the back end is working, right? And that agent is effectively connected with so many entities all together, and then the LM, which is the brain of the agent, is taking the calls to how to proceed forward into this, right? So basically you have a unified reasoning system, basically centralizes the instruction so they stay away from the consistent so it stay consistent across the different enterprise. So it's moving from a contextual memory, so it's kind of just move entirely to understand how the context is for the entire system, right? So it now knows, the agent is effectively now knows what happened 5 minutes back and what happened 5 months back, right? Simultaneously. So it basically broke all the whatever the context that the human used to have earlier by uh, providing a dynamic planning and a self correction mechanism, and migrating the analyzing the, let's suppose, the code, or drafting the change, sandboxing the change to see if it compiles, and then critique its the error logs, that if there's some error coming, why is it coming, and all that criticization that is doing, right? So this intelligence layer is now introduced into the business, right? So when you look into the multi-agentic architecture, you particularly see in 2026, the unit of enterprise AI is now not the model, all the LLM model that used to be. It's the squad of the entire multiple agents in the picture, right? So the multi-agentic architecture allow is to implement a hierarchical control that used to be there with different organization. So you have a manager agent who that manages the worker agent, just like a hierarchy in a enterprise, right? So it creates a massive reduction in the hallucinations that used to happen when there's a single model in the picture that used to be in 2024, 2025, right? So it effectively happening when a model is forced to fulfill a role. So usually hallucinations particularly takes care because it's like too much of the work that a single model has to do. Now hallucinations happen only when a specific model is doing a task that is not supposed to do. Let's suppose I have a financial agent that effectively do financial calculations across an enterprise, and I'm asking that financial agent to do operations in the enterprise, right? It is not supposed to do that, like just like a typical human do, right? You cannot ask a financial analyst to become an operation manager, right? It cannot do that, right? So in same way, the hallucinations that are happening within these models, and they're particularly not performing up to the mark, only happening when a specific agent is now doing a fulfilling a task that is not it was trained to do, right? So in that way, if you look into the scalable workflows potential, you can now duplicate a squad 1,000 times, where you can view the entire month's worth of financial transactions, let's suppose, in just minutes, right? With each transaction being fully vetted by, let's suppose, three different agents who are working on the financial agentic system. And basically, horizontal, it's kind of basically you can call it this is a horizontal scale of intelligence, a scaling of intelligence, right? So effectively, you are now having agentic systems where you can scale those agentic systems for, let's suppose, if I have three agents to like 1,000 agents doing it, right? Where I'm just duplicating the squad effectively, right? So if I have a group of three agents performing a task very well, I can deploy to 100 other places to do the same task, right? So that's basically the scalable workflow potential I'm seeing. Going to the next slide, engineering the intelligent supply chain. So this is one of the another use case that you can take it up, right? So in 2026, supply chain is effectively orchestrated network, right? Your in the earlier times, in the previous times, supply chains were very reactive in nature, right? You only knew something was wrong when the shelf was empty, right? In a, let's suppose, in a typical manufacturing shop, or retail shops or something like that, right? You when you know that okay, there's this material that is not there and I need to place an order for that, you are basically being reactive. That you don't have a plan already, but you're being reactive to it, right? Most of the places it happens already. You might assume that you'll take a guess that this inventory will get over by in a week, right? And then you try to do a planning for it, but it's already always a guess, right? It could particularly be get over in 2 days, and then you'll be sitting waiting for the shipyard shipment to come in a week, right? So you're being reactive to this specific case. What is happening with the agentic AI system is it's moved to a predictive orchestration, right? It's predicting on that way, that is having all the parameter that is required for this particular inventory to finish. Will take this inventory to almost like a 3 days to particularly finish, right? And it's calculating those predictions, and then taking action accordingly. Do I need to place a new inventory in the system, right? So the agentic control tower effectively monitors the global event that are happening across different organizations and department 24 by 7, right? It correlates the even the weather patterns, like if the shipment is coming from some other location where there's raining, or if there's a possibility of raining, then there's a possibility of delay in that location. That suppose it's raining in Delhi and I need a shipment in Bangalore, there's a possibility of delay. It might effectively can correlate that, and then put it up in the overall calculation of when the shipment will come, right? So it basically correlates the weather patterns, the congestion data, internal sales forecast, and if it predicts a shortfall, it doesn't effectively alert you. it starts an autonomous procurement in terms of how it should be particularly performed, because there is some blockers within the task that is performing. So it identify these pre-vetted secondary suppliers, or shipping windows and everything, right? And then present it to the, let's suppose, a CEO of a company or a supply chain director, with a single says that approve or disapprove. This is the plan that I made. This is how it's going to be executed in 3 days. These are the challenges and blockers. Do you want to go ahead with this or not? And it just gave the director a button that approve this or do not approve this, right? So it's an actionable insight. So AI has done almost 99% of the work, the searching, the negotiations, and the human is provided the final 1% of the strategic authorization of, let's suppose, pressing approve button or taking a call if this is something that needs to be done.
Okay, so on the right is effectively an agentic AI system. It's effectively proactive, stateful, and integrated. Basically, it's basically completes the goal. It look at the memory architecture. Wherever in case of a standard AI, you have a context window that eventually fill up the and forgets. In the agentic AI uses, it has a persistent stateful memory via vector databases or vector clouds. So it never forgets a customer's preference once it's set, right? So to take up into this consideration as a leader in your organization, your return on investment is found on the right side of the table, which is on the agentic AI systems, where every project you approve in 2026 should be audited against this spectrum. So if you are building a passive system, you are building for 2024. If you want to win in 2027, you must engineer for proactive and self-correcting loops, which is basically what an agentic system provides, right? Okay, so moving to the next slide, the governance and execution strategy for a company are only as good as the data they access, right? So effectively, you have to prioritize building a unified and high quality data fabric first. That means your data strategy should be on point, where you are storing the data, what data are you storing, how is it structured, how is being fed to an AI system, all of this, all of this first. So having a robust data foundation is a necessity for a successful agentic AI implementation. Um, Next important thing is on the side of how implementation human in the loop controls are happening, because you don't want to build a system that is completely out of your loop in terms of how it's basically performs in the real world use cases. So having a clear approval threshold where an agent must pause for a human signature before the final execution is absolutely important. The next thing is basically taking care of the agentic drift. So if you have been basically been in the machine learning era, there's something called a model drift. The same model drifts effectively come as part of the in agentic system as an agentic drift, right? So effectively, you're continuously auditing the reasoning loops of your agents to ensure that they aren't becoming less efficient and not losing their edge in making the right decision for the task that they've been performing, right? So making sure that they're not aren't becoming less efficient or safe or less safe over time, right? And the fourth thing is modular skills. So building agent with specific skills or APIs that can be reused across different departments like HR, finance, IT, wherever you're deploying a specific agentic system, right? So that is a few of the governance and execution strategy that you should particularly look at. Uh, Moving forward, so for enterprise leader, so summarizing the executive landscape for 2026, the agentic inflection point, as I can call, is basically where the Gartner, one of the reports from Gartner, it says that 40% of the applications in in the coming year will be agentic by the year end, right? which is the fastest adoption curve in the entire technology industry, right? The return on investment gap will be 95% of the chat pilots are failing to show the profit loss impact, and because they don't do anything effectively, the agency changes the ROI calculations. So earlier, when you effectively build a chatbot using an LLM or something, these chatbots are more human driven, and they effectively are not, intelligent enough to perform most of the tasks by themselves, right? Now the agency actually changes the return on investment calculations, right? Now governance effectively, like companies like, whatever the auditing companies are there, are putting up the strong governance layers that are actually scaling the, fastest, because they're, the team that is building these agents effectively seems delegating the task to the AI, right? So the top 15% of, if I talk about the CEOs of, are basically not running the pilots right now, right? They're performing the end-to-end reinvention of the entire strategy, right? Yeah. So basically, they aren't trying to make their employees 10% faster. They're trying to basically process 10 times more valuable through agentic squad, right? So effectively, you're not trying to see that, hey, I can make my humans sufficient by, letting them use the AI for their job. Obviously, you will be doing that. But if you build agents, your all of the workflows will be more almost 5 to 10 times faster, right? And it will basically become an agentic squad to do it if you implement it correctly with proper governance and execution. So the conclusion that we have is effectively the strategic insights for the enterprise leaders, where, all of this is effectively leading you to become more efficient into your overall workflows. And the implementation and the is going in the industry is beyond the pilot phases right now, and it's effectively going into the traditional ecosystem by, making sure that, you are make having a stricter governance so that you can particularly feel safe in delegating the task to AI. So I think that's more or less for this session. Thank you for uh, staying for some more time and listening to me on this one. If you have any questions, feel free to, ask it on the chat or speak up. I'm happy to answer this.
Thank you so much, sir, for your incredible insight. So, if anybody has any questions, you can just ping us in the chat box and we'll take it from there.
Traditional. Okay. So,
Okay.
yeah, I mean,
Yes.
for healthcare use cases, I mean, it's you have PII and PHI informations that are effectively you deal with, and a traditional IDP effectively has, a lot of changes in the workflow that happens, and there are more regex or pattern based identifications, and as well as, if you need to have some entities extracted as a form of a retrieval for a specific query, they are also challenging to do because of the changing nature, or, deterministic nature of the previous previous solutions that used to be there for agentic. With the multi-agentic flows, what we essentially has innovated a lot is majorly on how the extraction for a different entities, like, tables or text or nested components within the specific document is happening, and they are particularly either done through multiple passes along the LLMs, or, multiple agents that are effectively performing specific tasks within them, depending on the business use case. So let's suppose take a use case of, I want the numbers in my documents are important because the numbers represent majorly the cost values. And if the business is asking what is the latest cost value for a specific workflow that is assigned in a specific document, I would particularly wanted to give that exact number out. So identifying, building metrics around that effectively identifies those specific numbers as one of the things are some of the areas that you specifically focus from the business perspective. So creating these success metric or evaluation metrics around those. And then once we wanted to move to a generic document processing system, you particularly have to look for components that doesn't require you to be more specific to a use case. So something that I automatically process most of the important entities within it, where the tables and normal text around it, columns around it, and maybe using through a LLM based approach for extraction, or particularly trying to using a GPT or Dockling or different DeepSeek based models for most of the OCR extractions. There are retrieval components to it that you effectively can build, using encoder models or models which are effectively good for transformer based models which are effectively good for retrieval components. You can improve over there and then particularly add some answer extraction modules to particularly go for extracting those things up into. And then you can package each of these into certain agents and connect building a flow around these. So orchestrating it through orchestrating to two different tasks like the extraction and the semantic retrieval, and then trying to see the overall output and then give the final output to the final orchestrator, gives the final output to you know uh, the overall business, right? So all of this is system is effectively chunking these specific tasks into agentic systems or multi-agentic systems, with each agents performing the specific things and then executing them within those specific agent boundaries. So I think that would be the approach that we can move forward with, but try to ensure one of the most important thing is how generic and usable your system is. So if I have changes happening in my document, I'm not stuck at adapting my script to that specific change or adapting the logics behind it, right? It's just a semantic layer that effectively understand what is happening, or what specific small changes that happen and can adapt to those changes, does not break the system in that way. So more or less the semantic layer and the reasoning behind the extractions of the agent would be more useful in these use cases.
I guess, and that answers the question to, yeah, to Mr. Arvind. And then we have another question for you, sir. What are some key benefits of adopting agentic AI in businesses?
So, like I discussed in the entire, presentation, more or less there are a lot of ROIs while you are adapting it. The most important being how the improvement in the efficiency gains that you effectively seeing in the previous intelligence layers that we put in the tech industry has become multifold in these cases. So if you're saying that I'm building this intelligence layer of RP automation or something like that, or maybe like the 2024 era, AI chatbots, I was increasing the efficiency by 10%, 20%, 30%, maybe like 50, 60% around, right? In this cases, instead of improving the efficiency, I am changing the actors into this, where I am particularly trying to see how the specific task has been performed by agents, and those tasks has been performed autonomously, where it effectively resolve the specific time to completion much faster, from like days to like minutes, right? And that gain is very 100 times or multifolds or 10 times, 50 times than what used to be earlier, right? So it's not talking about days, not talking about minutes to solve that specific task, right? So the agentic revolution is effectively doing it 10 to 100 times 50 times magnitude compared to what the generative revolution tried to bring, right, in the 2024 2025 era. So a lot of key benefits is the entire workflows of the businesses can be engulfed into an agentic workflow, where each agent performs a task what a human effectively does on a regular basis, where the human is particularly required to majorly supervise these agents that they are not taking unethical routes to perform those tasks, and it's well within the guardrails of what a business entails to perform something, right? So There's the direct key benefit, which is the major one, is the multifold improvement in the efficiency of the overall business.
Thank you, sir. Thank you for that insight. I hope your question has been answered, Mr. Arvind. Thank you so much. So that's all for the day. Thank you, Mr. Sumit Jain, for sharing such powerful and practical insights. And thank you to all the attendees who joined in and took us like a thoughtful audience, I would say. So thank you everyone who joined it. And again, thank you to you, sir.
Thank you so much for everyone for your time, and looking forward to see you in future.
Same here, sir. This is Survi Sahai signing off on behalf of India IT 360. Stay ahead, stay involved. We look forward to seeing you at the next session. Have a wonderful evening ahead. Thank you.